Good morning, everybody, and thank you for joining the September 2025 CAD training. This month's topic is Civil 3D intersections. I'll be doing the example in Civil 3D 2026. It shouldn't make a difference if you're using 2025, but I just wanted to put that out there so everyone knows at the time of recording what was used. So, per normal, PDF and a sample CAD file were sent out this morning. They're located on our S drive. Please feel free to download those and follow along. Okay, so to start out with intersections, we first need to talk a little bit about how they work because they're kind of a complicated thing within Civil 3D. For this training session, we're actually going to have the presentation be a little bit shorter than normal so that I can do a little bit more with the exercise itself and then allow a little bit more time for questions than normal if anyone has them. So how does Civil 3D intersections work? Intersections can be created in Civil 3D and then they're incorporated into corridors. Sometimes we make them their own corridors, or sometimes we incorporate them into the corridor of one of the streets in the intersection. There are some prerequisites for things before you can create an intersection. For example, 2 or more alignments that intersect each other need to be in your drawing already, and they need to be profiled. You also need to have an existing ground surface if you want it to tie off to the existing contours, and you need to have assemblies and sub-assemblies as required for the intersection parts itself. So within Civil 3D, there are 2 main methods of creating intersections. There's a wizard to do it, which I'll show a little bit, and then there's also a method of creating regions within corridors to do basically the same thing. A couple notes. The wizard walks you through. It uses a system of dialog boxes. It's very step-by-step. It tends to take a little bit of time, but it's very thorough. And as opposed to the method of creating with regions, this allows you to use either a feature line or a separate alignment that's run along the face of curb for the curb returns. And then you can use that as the basis for a corridor region and have it target the profiles of the intersecting streets. That's the method we're going to show today. So, of those 2 methods, which one should you use? In my opinion, creating regions within the corridors is much easier than using the wizard. It gives you more control over how the intersection itself is created, and it tends to be easier and faster. I've had issues in the past using the wizard where it actually changed the profiles of my roads, and I didn't know it until much later, and it made it kind of difficult to put things back to where they needed to be. The reason for this is because it uses some set of design criteria that you can't control, but it's baked into Civil 3D, and it automatically adjusts everything to fit that set criteria. As a result of it changing the road profiles, it also changed the top grade elevations on storm sewer inlets, top of castings on manholes, adjusted all kinds of things, messed up crosswalks for curb ramps. I find that using the corridor regions method instead allows you to manipulate all parts of the intersection without messing up your horizontal or vertical geometry that you already have figured out. Another thing with the wizard is that you need to have a lot of assemblies pre-configured, which I'll show when we get into the example. But whenever you do corridor regions, you can control which ones you use and which ones you need. And again, we'll get into that. So speaking of assemblies, this is a list of all of the assemblies that you could need when you create an intersection. When you use the wizard to create it, you would need every single one of these in your drawing. So that would be a total of 2, 4, 6, 8, 10, 11 assemblies that would need to be customized and created just to make one intersection. When you use the corridor regions, like we're going to do in our example today, you only need 3, and they're already in the template. You just need to adjust your road slope and cartway width and curb height. So it's a lot easier, a lot quicker. And to me, once you do it a couple times, it just is a little more intuitive and makes sense. Okay, so how do you create an intersection within Civil 3D? For this, we're going to jump over to Civil 3D. And I have the sample file open. Like I said before, it's located on our S drive. If you want to open that up and take a look, please feel free to follow along. If you have any questions, please also put those in the chat. I'm going to try to pay attention to that as we go. If you have a timely question and I don't see it in the chat, feel free to unmute yourself and ask. The presentation part of this is pretty well over, and at this point I kind of wanted to get into the meat of it to make sure everybody gets a chance to try it and have your questions answered if you have them. So don't be shy with them. All right, so a little bit of background. This file is for a parcel that's going to be subdivided into single family lots. It has an existing surface. It has an alignment for each of the 2 proposed roads. So for the sake of the example, we have road 1 right here that goes to a cul-de-sac, and we have road 2 that comes off of the existing road and intersects with road 1. We're going to be working on the intersection here of road 2 and road 1. Both road 1 and road 2 have alignments and profiles already created. So we're going to create the 3-way intersection off of those. I did want to note the corridors that are in this drawing. I stopped them at the right-of-way line instead of having them tie off to the existing surface. That's mainly because I wanted to focus on the intersection itself and not on cleaning up corridor tie-offs. I think that's kind of a different topic for a different day. If you're doing this at some point on a project and you have an issue with that, please let me know and I'd be happy to try to figure it out with you. Okay, so the first thing we need to do to create our intersection is we need to get the corridor regions out of the intersection area. There's a couple ways to do this. I'm going to show 2 of them. So for road 2, to get it out of the intersection, I'm just going to grip edit it. So I'm going to click on the diamond grip, and you can see the grip slides along the center line. So given that, I'm going to object snap to the end point of my curb return and click, and you can see it pulled the corridor region back. So that's one way to do it. Now we need to handle road 1. This is going to be a little bit different because we essentially want to create a hole in the corridor where the intersection will be. To do this, we're going to enter the corridor properties. And here you can see in the parameters tab all of the parts that go into a corridor. In this particular file, there are only 2 roads and they're relatively short, so I made 1 corridor. If this was a project that had multiple roads and there were multiple intersections and it was more complex, I would probably do a corridor for every one of the roads just to keep things a little bit cleaner. In this case, it really wasn't necessary, so I found it easier to keep them together. So to split this corridor, what we're going to do is right click on the road 1 region that's already been created, and we're going to click split region. Now it closes the dialog box and it wants you to select where you want the split to occur. So what we're going to do is object snap to the end point of one of the curb returns and click, and then I'm going to press enter to end the command. And now when the dialog box reopens, you can see that there are 2 regions in the drawing. So I'm going to hit apply and rebuild it. And I'm just going to close the dialog box long enough to zoom out so you can see what I have now. So now you can see it put a set of grips where I split it because it has 2 different regions. I'm going to jump back into corridor properties and finish clearing this out. So the way I'm going to make up this gap is by shortening the first region of the corridor. You can see when you click on them in the dialog box, it selects them over in your window here. So I want to shorten this one. To do that, I'm going to go over to the end station column and click on the glyph here. And I'm going to object snap the opposite curb return from where I started. So I'm going to grab here, grab the PT on that curve, hit apply, rebuild, and OK. Now you can see there's a hole here, which leaves us space to create our intersection. So, as we talked before, the prerequisites for creating the intersection are the alignments and profiles and corridor, which we have. The next thing is the assemblies. So I'm going to look over to the left side of my split screen. This is the assemblies section of our template. What I like to do is separate the ones I'm using in my drawing. So I just created another column over here and called it PR Roads, which is the name of the site I'm using for all of this stuff. And then I have the one assembly that's in the drawing being used to create Road 1 and Road 2. So I have that. I'm also going to need a half section. So that is going to be used to fill the gap on this right side of the road going through the intersection. And then I'm going to need an assembly for these curb return radiuses. So what I like to do is jump into the list here, and I'm going to find the two sub-assemblies, or the two assemblies that are closest to what I need. I'll copy them up into my segregated column here, and then I'll adjust the parameters. So the first one I need is called Road Half Section Left. So I'm going to look for a sub-assembly or an assembly that looks like half of a road. It is one of these two, I believe. So when you select on an assembly, you want to grab the green line, and then in your Civil 3D properties, if you go to name and highlight over it, you can see the name. In this case, it says Primary Road Half Section Daylight Left. That's the one we're going to use, so I'm going to copy that, and I'm going to move it up and put it just below the other one I'm using. And then I am also going to find the curb return sub-assembly or assembly that I need. I believe it should be this one. When you're doing the curb returns, you want to look for the assemblies that have the green line along the face of curb instead of the center line, because that's the basis the corridor tool is going to use to create the regions. So I'm going to grab the curb return fillets with no daylight. I'm going to copy that. And put it up here as well. So now that I have all three of these, I need to modify my two new ones to match the parameters of my road, curb, grass strip, and sidewalk. So for this particular example, if I select the crowned lane that I'm using right now, and I go into the properties and scroll down to parameters, I can see that this road has a 3% cross slope and 10-foot lane widths. So I'm going to deselect that, and I'm going to put those parameters into these. So these sub-assemblies are called Lane Super Elevation AOR. What they allow you to do, and what these little flag looking things mean, are that they can target other items, which allows the width to actually be variable if it needs to be. And I'll show you how that works in a little bit. But for now, I like to put the base parameters in. So I'm going to scroll down, set the lane width to 10 feet, set the default slope to -3, and then hit escape. And I'll do the same thing to the lane in the curb return. 10-foot width, minus 3% slope. Now you can see when I hit escape here, it disconnected the curb. If you regen, it should move it back to where it needs to be. All right, next thing I need to do is the curb. So I'm going to select the curb. In properties, I'm going to scroll down to parameters. And I need to update the width, depth, and depth below. For this example, we're using an extruded mountable curb. So the width is going to be 0.875 feet. The depth is going to be 1.5 feet, and the depth below is 1.12. A little note on that, the actual depth of this curb, if you look at our detail, is not 1.5 feet, but you need to provide a certain depth so that Civil 3D can set the curb reveal. So 1.5 minus 1.125, the depth below, equals our desired curb reveal of 0.375, which I believe is 4.5 inches on extruded mountable curb. So I'm going to copy these parameters over to these curbs in the proposed section. So I'm going to deselect. I'm going to grab the first curb for my half section. For some reason, it doesn't want to let me select it. If you run into that issue, for some reason, it won't do it. And if you window across everything and then just deselect what you don't want by holding down Shift and then windowing until all you have left is the curb, that's a workaround. I'm not sure why it sometimes doesn't want to let you select the curb. Okay, so if we go to width, we're going to set that to 0.875. The depth is already 1.5 feet, and we're going to set the depth below to 1.125. There, it adjusted the curb. It matches the one up here, so we're good to go on that. I'll do the same thing to this curb. 0.875 for the width. The depth is 1.5. The depth below is 1.125. Okay, next we need to do the grass strip. It's the same deal. The grass strip is 10.125 feet in width with a 2% slope. So I'm going to select the grass strip for the half section, key in the 10.125 foot width. 2% slope is there by default. We'll do the same thing here. 10.125 and 2%. And then we'll do the sidewalk, which the property parameters for that has a 4-foot width at 2%. So we will select the sidewalk in the half section, make it 4 feet wide at 2%. And the same thing for the curb return, 4 feet, 2%. And for this exercise, I'm going to delete the daylight subassembly off of this. So these are your finished assemblies for this exercise. Something I like to do, because there are a lot of assemblies in the template by default for different situations, is I like to rename the ones I'm actually using. So what I'm going to do is select the half section. I'm going to go to name and properties, and I'm going to call it PR Roads half section. This is going to make it easier in a few minutes when we have to find these in a list of all the assemblies to actually be able to use them. So for the curb returns, I'm going to go PR Roads curb returns. Okay, at this point I'm going to save my drawing. And now that we've done all that upfront work, we are ready to actually do the intersection. Real quick, I do want to point out, I know that sounds like a ton of work, and it kind of is, but now that those are created, if this was a drawing that had 2 or 3 intersections in it, you would just reuse these same assemblies again. So I have a project that I did it and had, I believe, 5 intersections. I was able to reuse all of the assemblies, and it made it not too bad. It actually made it a lot quicker whenever I needed to do an intersection because I already had things created. It was quicker than grading it by hand. And it could be incorporated into the surface as far as doing spot elevations, which was nice. Okay. Next thing we need to do, we need to create a couple feature lines for these curb returns. So I'm going to set my active layer to PR feature line. And I'm going to do feature lines by polyline. I find that to be the easiest way to go for me. One thing when you are doing this, the direction that you draw them matters. The way you need to figure out which direction to draw is by looking at your curb return subassembly. So for this one, the road section is on the left side of your green baseline. That means that we want to draw our feature lines going clockwise around the curves. So I'm going to go ahead and draw the polylines that way as well. I'm going to start here, just go endpoint to endpoint, and endpoint to endpoint. And now I'm going to turn those into arcs. If you've never done that before, all you do is select a polyline, mouse over the midpoint grip, and then hit convert to arc, and you can select where you want that arc to go. So I'm going to object snap to the midpoint of my face of curb, and now I have 2 polylines here that are ready to go. At this point, I'm going to create feature lines from objects, select my 2 new polylines, and when the create feature lines dialog comes up, I'm going to put them on my PR roads surface, which is the same, or site, which is the same that I'm using for the other road features. I'll leave them on the feature lines layer, and I'll erase existing entities and hit OK. Okay. Next up, I'm going to assign elevations to these. So to do that, I'm going to select one of the feature lines, click on the elevation editor. When that comes up, I'm going to click the button for assigning elevations from surface. It's the one that has the little surface symbol in it. So we're going to click on that. We're going to use my corridor surface, which is called PR Roads Surface 1 in this case. And I'm going to hit OK. When I do that, you can see that we have elevations on here. I'm going to do the same thing for my other feature line. So I selected it, hit the elevation editor, hit my elevations from surface. It still has my corridor surface selected, so I'm going to hit OK. Okay, now that we have elevations and slopes on those, I want to look to make sure I'm going to have drainage along my curb lines. So for this particular one, 3.8%, that one's good. I believe this one was pretty flat, so let's take a look. Yep, 0.25%. So one of the advantages of doing this using the feature line and the corridor regions is I have control over the slope along this curb return. If you were to use the wizard, it's either going to mess up your profiles to make it work, or it's going to leave them flat. I'm not entirely sure how it decides what it's going to do, but I don't really like that it decides for me instead of me making that decision. So since I know this is flat, I think what I'm going to do is add a high point in the middle and run 2% out in either direction. So I'm going to put an elevation point. I'm going to object snap to the midpoint of my arc. I'm going to accept that, and then I'm going to open the elevation editor back up. And here you can see I'm going to change this grade ahead from minus 0.25 to positive 2%. So now I have 2% up to the midpoint, and from the midpoint back down at minus 2.5%. One thing you want to check if you are dealing with a road that has a larger curb return radius and you need to do this, make sure the midpoint elevation you're setting is still below the center point in your intersection, so you don't create a weird drainage situation where the water is flowing away from the curb line. I already checked this one, and what it's going to do, it's still pushing the water to the curb line, but it's going to vary the cross slope slightly through the curve so that the water also pushes away from that point instead of ponding. So just a note on that. Okay, now that we are there, I'm going to save my drawing again. And we're going to get into the corridor part of this. So I'm going to select my corridor. Actually, before I do that, are there any questions before I move forward? I don't see anything in the chat. I'll give you a few seconds just to make sure. Okay, seeing none, we'll move forward. So I'm going to select on the corridor, right click, and I'm going to go to corridor properties. Now that I'm in here, I need to create two new baselines. A baseline is like what alignment the corridor is reading. In this case, I'm going to use feature lines as a baseline instead of an alignment. So this corridor already has a baseline for road 2 and road 1. We're going to create a baseline. And when I click the Add Baseline button, it brings up the Add Baselines dialog box. In this case, I'm not using alignments and profiles. I'm going to come down here to feature lines. I'm going to hit the glyph to pick in the drawing window. When I do that, it's going to ask me to pick one of my feature lines. I'm going to select this one. You can name it if you'd like. I'm just going to leave them as feature 1 and feature 2 for this exercise. If you had multiple intersections in your drawing, I would probably do the names of the intersecting roads and then maybe the quadrant that the curb return is in. So this one might be road 1 dash road 2 dash northwest. And the one down here could be road 1 dash road 2 dash southwest. The names get a little bit long, but when you're dealing with lots of corridors and lots of baselines, having those names be specific is way easier if you need to get into that in a month or two and try to figure out what you did. So for this exercise, in the sake of time, I'm going to leave it as default, but that's a good practice. So now that I selected that, I'm going to hit enter to accept it. It brings the Add Baselines dialog box back up. You can see feature 1 has been selected. Now I need to give it an assembly. So I'm going to hit the drop down and I'm going to look for my PR roads curb returns that I created before. I'm going to select that and I'm going to hit OK. Now I'm going to repeat that again for the other curb return. So I'm going to add baseline, down to feature line section, hit the pick box glyph, select my other feature line, feature 2, hit OK, and enter. And then within the dialog box, I'm going to assign the assembly to be PR roads curb returns. And now I'm going to click OK. From here, I'm going to hit apply. It's going to prompt me to rebuild the corridor, which I'm going to do. And now you can see it added 2 corridor sections. They're running along the curb, but the lane widths are exactly 10 feet wide. The next step we're going to need to do is tell the corridor to run the lane width all the way to the center lines of road 1 and road 2, and tell it to tie in to those profile elevations. Within corridors, they call those targets. So what I'm going to do, I'm actually going to close the corridor properties dialog box because I don't like that it still has the out of date glyphs here. So I'm just going to close that. You can see the surface updated. It looks a little funky because it's not targeting the profile of the road. But now that that's updated, I'm going to go back into the corridor properties again, and it cleared those out. So now I'm going to work on feature 1's corridor region, which when I select it, you can see it highlights the baseline, and it is this section right here. So I'm going to go ahead and set targets for that baseline. So I'm going to select the baseline, and I'm going to run across to the target column and hit the box with 3 dots in it. From here, I want to be in the offset and elevation tab because I'm targeting a width on the alignment and an elevation on the alignment. I'm not targeting a surface, so I don't need to do anything there. Okay, so within offset and elevation, I'm going to set the width target first. I'm going to go to where it says none under offset. When you select that, you can see it brings up 2 columns over here. You can tell it to target polylines, survey figures, or feature lines, but in this case, I'm going to select alignments. In this drawing, there are only 2, so I'm just going to check road 1, road 2, and then I need to tell it what elevation to target. So I'm going to go to outside elevation target. I'm going to run across to where the elevation says none, and now I'm going to go into the profile and pipe target section, and I want to find the profile for road 1 and for road 2. So here you can see these are surfaces within the drawing. I'm going to go until I see road 1, and then I'm going to scroll down and I'm going to find road 2, check those, and hit OK. Now when I hit apply and rebuild, you can see it expanded the corridor out all the way through to the center lines of the roads. Next up, I'm going to do the same thing for the second baseline. So I'm going to hit feature 2, go to target. I'm going to go to offset and elevation again and go to width. Right now the offset is set to none, so we're going to click on offset and select the 2 alignments. Then we're going to go up to outside elevation target, click on elevation, and in our list on the left side, find road 1 and road 2, and hit OK. And apply, and rebuild, and OK. Now you can see the surface adjusted. It's hitting the face of curb, it's hitting the center lines of the road. The slopes along the center line should match the profiles exactly, which is exactly what we want. Okay, next up, we need to finish the intersection by just filling in our half section over here. So to do that, we're going to jump back into corridor properties one last time, and we're going to add a new region to the road 1 baseline. So the road 1 baseline is the center line of road 1. Since this half section is going to follow that center line, we want to put it under that baseline. So I am going to add a region between the 2 regions that are already here. To do that, I'm going to click the first region, and then I'm going to right click and say insert region after. It's going to pull up your dialog box for create corridor region. I'm going to leave the region name alone. You can name those if you'd like, but for the sake of time, I'm going to leave it. What you need to change is the assembly. So hit your drop down, go to PR Roads half section and click, and then hit OK. Now it's going to want you to update your corridor, so we're going to do that. You can see it filled it in, but notice that the cross section lines are a lot further apart than they are on these sections of the corridors. That can be controlled by what is called the frequency. So what I want to do is change the frequency of my new section to match the frequency of the rest of road 1. To do that, I'm going to first get out of the corridor properties so that it'll update, because you can see the update glyphs are still here, so I'm going to hit OK. It added my surface through here. Now I'm going to jump back into corridor properties, to finish this. So here I'm going to click on the region I just created. I'm going to go to frequency and click on the dots. It opens the frequency to apply assemblies dialog box. And we're just going to change this value for the horizontal baseline along tangents to 5 feet instead of 10 feet and hit OK. Now when I apply and rebuild, now you can see the lines are 5 feet apart instead of 10 feet. I'm going to hit OK. In this case, the surface did not change. What you'll notice on other projects, that frequency is going to determine how clean your surface ends up, especially if you're in vertical curves. It can have a really big effect. Or along horizontal curves, like we are down here, you can see I tightened the frequency because I wanted these contours to exactly hit the face of curve and top of curve and not jump around and have odd angles because it's only sampling elevations every 10 feet or 5 feet. So that's something I usually adjust. Okay, so now we have one corridor. It has road 2, road 1, and a finished intersection. The last thing I like to do is just preview it to make sure it looks right. So I'm going to click on it, right click, and I'm going to add to model viewer. If you're not using Civil 3D 2026, you do not have this option, I believe. So in my opinion, it's worth updating just to be able to do this, because you can do it for pipe networks, corridors, surfaces, and it gives you a 3D preview of everything. So here you can see we have our road corridors. There's a curve here. You can see it held the intersection. You can see the curb reveal, the sidewalk. If you look closely along here, you can actually see where I put the high point in the center of this curb return, where it's sloping down at 2% and down at 2.5%. The one on the other side, you can see, is sloping down the whole way along it to drain the water away. And it just gives you a really clean surface, and this is a nice way to make sure it worked correctly. Okay, so with that, are there any questions? I know this was kind of a shorter training session with a longer CAD segment, but I really wanted to make sure everybody got an opportunity to see how this works. And I'm sure you'll have questions if you don't right now. I'm sure the first time you try it, maybe you'll run into a roadblock. Feel free to refer to this video. Per normal, it's going to be posted to the Pantera YouTube channel for future reference, and the handouts and sample files will remain on the S drive. So if you ever want to try it again and follow through as a bit of a refresher, please feel free to do that as well. With that, I still don't see any questions, so I think we are going to call it at that. Thank you everybody for joining today, and we will see you next time.